Hey, welcome to class, Precalculus students. Today we are going to talk about parabolas. And let's just define what a parabola is. We know it as a U shape, but it's actually created from a line and a point. So on the screen you can see there's a given line in blue and a given point in blue, and they are equidistant from a set of points, and that set of points is a parabola. So this little point up here, that is called a focus, and the line that the parabola is equidistant from is called a directrix. So on page 21 of your Precalculus interactive notebook, you are going to put in these 4 formulas. So you can pause it if you need to, but I'll read through these. Okay, the first 2 have the x minus h quantity squared first. Both are equal to, and the first one is 4p, a positive 4p, and then a y minus k. The second one is just a negative 4p times y minus k. Now this one, first one, has an x squared and p is positive, so the direction of the parabola is facing up, and that's what you guys learned in Algebra 1, just the facing up parabolas. You reviewed it again last year in Algebra 2. Okay, for x squared where p is negative, that one is going to be a down facer. Now, those are old formulas, maybe just in a new form with the 4p. The second set is y squareds. These are the 2 new ones. You've got y minus k, and notice k stays with the y portion, squared, is equal to 4p times the quantity x minus h. And then y minus k quantity squared equals negative 4p x minus h. Now, this one's a y squared with a p positive, and it's going to open to the right. So we've never seen a left-right parabola. And then the second one opens to the left. Now, if you remember anything about functions, the little vertical line test, these last 2 are not functions because they touch a vertical line in more than one place. Okay, so let's practice graphing these. We're going to graph and state the vertex, the focus, and the directrix. The focus, again, is that point that's equidistant from the parabola, and the directrix is the line that is equidistant from the parabola, same distance from the focus. So the first thing we want to do is decide on the direction. This is an x squared, and the 4p portion is positive. Remember, 4p is on the side of the equation without the squared term. So if we have an x squared and 4p is positive, that means it's going to open up. So we can just put up. Okay, the vertex, we're just going to look for h and k. Now, if you go back to your formulas, I'm going to flip back for a second. Okay, it's x minus h. So since this is a positive 4, is always the opposite sign, so minus 4. And the same thing with the minus k, that's just positive 1. So these are always the opposite sign of what you see in the equation. Now, to find the focus and the directrix, this is what you're going to do. You're going to start first by plotting the vertex. 1, 2, 3, negative 4, positive 1. We know that the graph is going to face up. This portion, this 4p, is very important. I'm going to set 4p equal to that positive 12. That means p is 3. Now, 3 are the units you're going to count from this vertex to find your focus and your directrix. So since this is facing up, I'm going to go up 1, 2, 3. That is my focus. I'm going to put a little F there for focus. And I'm going to go down 3, 1, 2, 3. And that is the directrix, which is a line. Now, notice I am not drawing a solid line. The reason I'm not drawing a solid line, that line is not the parabola. That is a line of reference that helps create the parabola. So from here, I have my vertex, which I just got from H and K. I found my focus by counting P up. I found my directrix by counting P down. So when asked for the focus, we want to write this as a point or an ordered pair. So that's -4. And I went up 3 from 1, so that's +4. Now the directrix, I went down 3. 1, 2, 3. I'm at -2. Now horizontal line is always a y equals. Y equals -2. And that's your horizontal line. Now, how do I know how wide to make the graph? Well, this is very easy to do. What you're going to do is you're going to go to the focus. And you're going to count 2p to the left and 2p to the right. So I'm going to go to my focus and count 1, 2, 3, 4, 5, 6. 6 units away. Where am I getting 6? 2 times 3, which is 2 distances of p. And then I'm going to count 2 to the right, 2 p's to the right, 1, 2, 3, 4, 5, 6. Now, from the vertex, the parabola is going to go up through each of these points to the left and to the right. Now let's talk about that whole equidistant concept, okay? Every point on this curve is equidistant from this line and the focus. And let me just show you how. That distance is the same as that distance. The vertex is halfway in between. Okay, how about another one? Let's pick this point. So this distance from the focus to the point on the graph is equal to this distance. Those two are equal distances. Same here, this distance is the same as this perpendicular distance. Boom. So every point on this parabola is equidistant from a focus and a directrix. Now, those last few lines I drew showing you the equidistant part, those are not necessary. This is what you're going to graph when you're graphing a parabola. You're going to graph the vertex, the focus, the directrix, and then you're going to count 2p to the left and 2p to the right to draw how wide the parabola is. So here are some steps. You plot the vertex. Then you use p to count from the vertex to find the focus. Use p to count from the vertex to the directrix, and then you use 4p for the width, which is 2p to the left and 2p to the right. Okay, so let's try in the second one. Okay, again, you should be putting this into your your interactive notebook. So this time we have y minus 3 squared. So we have a y squared first. That's one of our left or right facers. We're going to look at the coefficient, which is 4p, to decide if it's left or right. Well, it's negative. That means it's going the negative direction, or it's going to the left. Okay, so which way is this one going? This is going left, which is going to face this way. Okay, our vertex. Now, you have to be careful. When your y squared is first, a lot of students say, oh, it's 3, -4, but it's not. You've got to look at h and k. H is always with x, so it's -4. K is always with the y, which is +3. Always the opposite signs. So again, let's plot our vertex first. 1, 2, 3, 4, 1, 2, 3. So that is our vertex, and I'm going to call it B just to make it easy. Okay, now we know we're going to go to the left and to the right this time instead of going up and down. We're going to go left and right for the focus and the directrix. Well, whichever way it faces is where we count our focus. So how far do we count? Well, let's take our 4p from our equation and set it equal to -8. Because remember our equation said 4p was equal to this number, so p is -2. Negative just means I'm going to the left. So I'm going to go to the left 2, and there's my focus. I'm going to go to the right 2, and there's my directrix. Now the directrix this time is up and down because I have a left-right facing parabola. Okay, so what are the coordinates for the foci? Well, from here, I went back 2 more, and so that's -6, +3. And my directrix is a line. This time it's a vertical line, so it's x equals -2. Okay, so there's my directrix, my focus. Now I need to know how wide my graph is. Well, since p is 2, or -2 in this case, 2p is going to be -4, 4. If you think about just distance is always positive. So you go 1, 2, 3, 4. From the focus, 1, 2, 3, 4. Always count this width from the focus. And there is the graph. There we go. So we just did a left-right facing graph. Hey, now let's look at how to change a parabola from non-standard form to standard form. So this will be page 23 in your interactive notebook. Okay. It says write the equation in standard form, state the vertex, focus, and directrix. So the first thing you want to do is look at which term is squared. So this one has a y squared. And you're going to move the c, which is our constant, to the other side, the side that has a variable that's not squared. So we're going to take this 39 and we're going to move it over to the non-squared side, which is the side that has the variable x. So that's our first step. Now what we're going to do is go to step 2. So that's done. Complete the square. So the squared side, we need to complete the square, and I sing a little song. You half it, you square it, and you add it to both sides. So you take the b term and you half 10 and square it. So I'm going to add 25 to both sides. And what does that give me? That gives me 8x squared. 8x plus 64 equals the y squared portion that I just completed the square on. So y squared minus 10y plus 25. Okay, so I've done that part, completing the square. Rewrite as a binomial squared. So the side we just completed the square on, it factors into y minus 5, y minus 5, or y minus 5 squared. So factor the right side. Now on the other side, so we've done that, we're going to factor out any coefficient. We have a coefficient of 8, so let's factor out that 8, and that leaves us with x plus 8. Okay, so now we can define our characteristics. Now we're going to look for the vertex, the focus, and the directrix. So let's look for the vertex first. The vertex is always equal to the opposite sign. So look at the x portion, that's -8. The y portion, opposite of that, 5. Okay, the focus, we have to look at what our coefficient is. So 4p is equal to 8. So p is a positive 2. So from our vertex, we're going to find the focus. So now I'm going to go to my graph. I'm going to plot -8, 1, 2, 3, 4, 5. And I know that is my vertex, so I'll call it V. My P is positive, so I'm going to go to either up or to the right, depending on which way this faces. Let's go back and look. This one is a y squared, which means it's a left-right facer. So it's going to face to the right, so my focus will be 2 to the right. So my focus is now at -6, 5. And then from the focus, I'm going to draw my 2 points. So I'm going to go up 2p in each direction, up and down. So up 2p, 1, 2, 3, 4. 1, 2p, another 2p, and there is my parabola. Okay, now I haven't finished because I still need to draw my directrix. And my directrix, if this focus is 2 to the right, that means my directrix is 2 to the left. So it's over here. And again, draw it as a dashed line. It's a line of reference. It's not part of the graph. It's a vertical line, so it's x equals -10. Okay, and that's how you find those characteristics to graph your parabola and find your clues. So I hope this was helpful on figuring that out. Now we're going to look at finding the equation of a parabola with a vertex and a focus given. I call these clue problems because you're given information and not the equation. So the first thing you want to do is graph. So I'm going to graph my vertex. My vertex is at 3, 9. My focus is at 3, 1, 2, 3, 4, 5. And let's call this F for focus and V for vertex so I don't get confused. Now, what this information gives me is the distance from the vertex to the focus, which is 4 units. So that means P is equal to 4. And since I'm looking for the equation, I actually need 4P. So multiply both sides by 4, and we get 4P is 16. Now, we can also figure out the facing. Because the vertex is above the focus, that means this one is going to face down. That means my P is not positive, but my P is actually negative. So when I go to plug it in, my 4P will be -16. Now, our skeleton equation for a down facer would be x minus h squared is equal to 4p times y minus k. Now, we know h and k is the vertex, and we have that. So let's plug in a 3 and a 9. So it's going to be x minus 3 squared is equal to 4p times y minus 9. Well, just a minute ago, we counted this distance p and decided it was 4, applied it to find 4p, and then made it negative because it faces down. So let's go back and replace 4p by a -16. And we have our equation. So the equation for the problem with a vertex at 3, 9 and a focus at 3, 5 is x minus 3 squared is equal to -16, y minus 9. Now let's look at our second clue problem. This time we're finding the equation of a parabola given its graph. And again, we need to think about the skeleton equation. So this is an up facing. So I know it's going to be an x squared. And since it's an up facing, it's also going to have a positive p. So I'm going to write the skeleton equation, x minus h. This is the squared portion, is equal to 4p, and we just decided this is going to be positive, times y minus k. Now we already know h and k, so let's plug in our h and k from our vertex. So I'm going to have x plus 1 quantity squared is equal to 4p times y minus k. Y minus negative 2 is plus 2. So always plug in that opposite sign. Now, we don't have the 4p, which we do need to find. And we don't know where the focus is, so that's not going to help us. But we do have a point. And what do we know about a point? The first position is an x coordinate, and the second position is a y coordinate. So that means I can plug in 4 for x and 6 for y into this equation, and then I'll be left with one variable. So let's plug in a 4 here, so 4 plus 1 squared is equal to, we don't know p, so bring that down. The y value is 6, so plug in 6 plus 2. And let's simplify this. So this is going to give me 5 squared, or 25. Bring down my 4p, and I have 6 plus 2 is 8. Now, you're going to be tempted to multiply 4 times 8 and get 32. I'm going to tell you, please don't do that. You're going to make your life harder. We need 4p for our equation. So let's just solve for 4p. So let's divide both sides by 8. So that means 4p is equal to 25/8. And we can stop right there and just plug that in for 4p with our vertex. So let's write our final answer, okay? Our final answer would then be x plus 1, because that's our x coordinate of our vertex, is equal to 4p, which is 25/8 y plus 2. And boom, we have the equation that we need given our clues of a vertex and a point to create the equation of the parabola. So let's look at a quick summary of what we did today. The first thing we did was write the 4 forms of the parabola equation. When we have an x squared, we have an up facer or a down facer. When we have a y squared, we have a left or right facer. We also learned how to graph a parabola from standard form and identify the vertex, the focus, and the directrix. Remember, the focus and the directrix are equidistant from the vertex. The third thing we learned how to do is how to change the equation of a parabola to standard form using CTS, which is completing the square. You have it, you square it, and you add it to both sides. And the last thing we did was learn how to write the equation of a parabola from clues. And we were given the vertex and a point, and the other one you were given a graph. So it's writing those equations given some form of a clue. So what are we going to do tonight? We're going to do worksheet 3 on parabolas.